notorious intro.
I don't put a face cam in. No.
Yeah, do you have an intro?
Do I have an intro?
Yeah, your
What's up, guys?
So let's get into it.
You know what? I don't actually have an intro, but I think I have certain sayings that I do.
Yeah. Every beginning of the lesson. So guys, let's get into it.
Okay.
Yeah.
Yeah. There we go.
Just make sure to intro like the line.
Yeah.
No, I'm not looking to monetize any of this. Just trying to save myself some work. All right, guys. So some of you guys have asked about how lotteries work. This question here is a bit of a simplified problem, but it's actually the math behind how Lotto 649 works. So here, this scratch and win contest allows you to scratch 5 numbers, and you scratch off your 5 numbers, and then the fun is, like, I guess some people consider this fun. You scratch off the 25 one at a time, and you kind of get a little pop of endorphin if like one of your numbers match. And then usually they give you like 4, and then like have you thinking you might win, and you get nothing in the end, right? But we can actually find out what your probability of winning such a lottery is. What we're going to be doing, the skill we're going to be using is just our old theoretical probability. So in all these questions we do today, to find the probability of some events, we're going to need to know the number of ways it can happen. We're going to need to know the number of elements in the sample space. And today's focus is just, we're going to use combinations to do that in general. So as you guys will probably see, nothing we do today is crazy new, just tying a couple things together. So the first thing we'll do is we'll actually find out, like, what's the probability of just winning the grand prize and getting your numbers right. And if you look at the ticket, it's hard to look at in detail for you guys, but it doesn't matter what order you get them in, as long as you get the 5 numbers. So in this question, since order doesn't matter, we'll be using combinations. So generally with probability questions, it's a good idea to think about, okay, what are the number of possible outcomes for the 5 numbers I have at the top that are my numbers. So of those 25 numbers, we're choosing 5. That's the total number of ways to choose 5 numbers. That number is not so big. We could just do it right now.
52,130.
Yeah, that's what I got too. And then, in this question, the number of ways to win, well, you have to get all 5 numbers right. So of the 5 correct numbers, there's just 5 ways to choose them. There's one way to win this grand prize. You have your 5 numbers are the winning numbers. And that's it. The probability of getting a win, I guess that's the probability, what I call P a day here. This particular lottery, it's just 1 out of 53,130. If you'd like to extend this to Lotto 649, you don't have to do this, but jot this down. But for Lotto 649, the reason it gets his name, do you guys know how it gets his name?
There's 640,000.
No, there's a lot more actually. It's because you choose 6 numbers from 1 to 49. So you choose your numbers, and if your 6 numbers come up in the draw in any order, you win the grand prize. And if you guys could just humor me, could you guys do 49 choose 6? See how big that number is. 49 choose 6.
13 million.
Yeah, exactly. It's like, yeah, so your chances of winning Lotto 649 are like 1 in 14 million. And like, so the jackpots for Lotto 649 aren't crazy big initially, but if no one wins, that keeps carrying over and carrying over. And so you can get pretty big prizes. The Powerball lotteries in the States have an even slimmer chance of winning, but like you can win like hundreds of millions in the States in their lotteries, yeah. you guys probably know, like in Lotto 649 other lotteries, you don't just there's multiple prizes. You don't have to get all the numbers right to win something. So here in this simple lottery, you get a second prize if you just match 4 of the 5 winning lottery numbers. So our sample size, the number of elements in our sample space here it's still the same thing as you got before. So you guys can just use that. For me on my slide here, I'm just going to rewrite that down. That was 53,130. But how can we calculate the number of ways to win a second prize? So get 4 numbers right. So we can frame it this way. We have to choose 4 of the winning numbers and 1 of the losing numbers. And we'll use combinations to do this because there's 5 winning numbers and you've got to get 4 of them. So 5 choose 4. This is kind of like questions we did in making committees with like a certain number of guys or girls or math staff and science staff. Of the 5 winning numbers, we're choosing 4. And of the remaining losing numbers, we're choosing 1. And FCP says we'll multiply those guys together. So 5 choose 4, I believe, is 5. And 20 choose 1, I believe, is 20. So that gives you 100. So your chance in this particular lottery, your chance of winning a second prize is just 100 out of 53,130. No, actually, those are pretty good odds for like a lottery. This is just a simplified one I made up. But in reality, that's how the math behind Lotto 649 works. Are you guys okay with what we did there? You guys agree? It's just tying some combinations into some probability. No crazy big deal. Let's try another one. Let's find a chance of winning a lottery. Let's analyze another committee question. Again, you guys have lots of experience doing this. Just now we're tying in probability. So we are making a prom committee of 8 people to be formed from 16 members of student council and 8 staff members. So you guys kind of should be trained by now to notice this, but that's 24 total people. And you've done enough of these too. You see that keyword committee, automatically you guys are thinking combinations because in a committee, the order doesn't matter. So in part A, we are going to find the probability that an equal number of staff and students are chosen. So that would mean 4 students and 4 staff of this 8-person committee. So let's do that together. So same process always, guys. When you're doing a probability question, a theoretical one, you got to find the number of elements in the sample space. How many committees of 8 people could you make? What calculation would you do? Anyone got that? Victoria? 24 choose 8. Exactly. 24 choose 8. And I don't think that's so big that we can't just do it and write it down. I don't think it is anyway. Okay, it's like a bit over 735,000. So that's how many committees we can make. But we want a special committee. We want it to be evenly split. So for our even split here, I like setting it up this way. You can set it up however way you like, but like we need to figure out how many ways can we choose our 4 students, how many ways can we choose our 4 staff. And I might actually let you guys do that. I'll wait like 30 seconds and then play catch up. You can try it. So we have 16 students council, 8 staff members. Somebody who hasn't helped out yet want to volunteer calculation that did, Sydney?
16.
Yep. Good. Yep. That's the way to choose the students. And 8 choose 4. Yep. Nice. I got 127,400. And then we've got it. So the probability of getting 4 students and 4 staff. You could also just write P at A here. It's fine. 127,400 out of 735,471. Now, maybe for this one, like to me, looking at that, that's not crazy meaningful. Those numbers are pretty big. I might want to find that as a percentage. So let's just get that as a percent really quick. Divide, multiply by 100. That's at 17.32%. All right. So, but if you randomly chose the committee, around 1 in 5 times, it'd be evenly split. Excuse me. Let's look at, let's ramp it up a little bit. So let's say, like, I think you guys would agree on a prom committee, you probably want more students, deciding the theme of your prom, et cetera, et cetera. So what if we need our committee to have at least 6 students? So that means 6 students or 7 students or 8 students. 6, 7, or 8. So part B here, guys, you can handle it. It's literally just like part A, because part A, you did the probability of getting 4 students, right? 4 and 4. So if you guys can do the same thing with the 6, 7, and 8, we just need to add those cases together, and you have the number of committees that have at least 6. So this is a little question where you're counting cases. We have the same number of elements in our sample space, still 735, 471. But you guys will need to do 6 calculations. So I'll maybe set it up and you guys can finish it off. So we can need to figure out how many ways can we get 6 students? How many ways can we get 7 students? And how many ways can you get 8 students? And then you got to total them up. But what calculation would you do in the middle there using combinations? As I said, you guys already did this question in part A, just you did it with 4 students. Now you got to do that calculation 3 times and then total them up. Maybe one of you guys can get the ball rolling. So what calculation would you do for getting 6 students? Anyone want to, somebody hasn't helped out possibly? Tristan, you got that?
16 choose 6 times 8 choose 2.
Yeah, great. And then 8 staff, because 6 students mean, or yeah, of 8 staff, we need 2. Yeah, that's good. Victoria, you had your hand up. How about the 7 students calculation?
16 choose 7 times 8 choose 1.
You got it. And then I got the last one. So 16 choose 8. And you could stop there. 16 choose 8, that's fine. It's just of the 16 students, you're choosing 8 of them. At this point, we know if you threw in the 8 choose 0 there, of your 8 teachers choosing 0, we know that equals to 1. So it doesn't really factor into the calculation. So as you guys finish this one off, this question was at least 6. It was 3 cases. If this question said find the probability that at least 1 student is chosen, doing 1, 2, 3, 4, 5, 6, 7, 8 students, that's a lot of calculations. Instead, we could find the number of ways to have no students and use the indirect method. So just keep in mind questions like this, which way would be faster. Here was faster just to add the cases up. I got 328, 614. How did I do? You guys get that as well? All right. So let's just put that state of final answer here and maybe put that as a percentage as well. $328, $614, $471. Divided by equals 44.68. All right, so you guys should be able to tie in combination questions we've done to probability. These are the types of questions I'd expect you guys to be able to handle. Are you guys okay so far? Anything you want to chat about? All right. The back you guys can handle, actually, because we spent our last day doing Plinko. I Googled and tried to find a little like miniature Plinko board, some game, and I found this one, this slam dunk and test your luck game. I think it's one of those, like, you know, those like little water games, or like where the things like float suspended in a bit of gel or something and like float down really slowly. It's one of these guys. And so the idea is the ball would just slowly go down to the bottom. But I want you guys, just like we did with Plinko, to analyze this guy. We're going to find the number of ways if we drop the basketball from the middle. So just to stress, we are going to go from the middle. So you guys can right away put a big 1 right in the middle there. That's where we're going to start from. How many ways can you get to the bottom? And then of those ways, how many get you 5 points? And then we can get the probability. So when you get down to the bottom, may not be clear, but it does kind of have to, the basketball will have to make a little left-right decision to fall into one of these bins. So just like it's just like Plinko.
I know, it's just where to put them.
So in between the pegs or like above the pegs. Yep. Yeah, I'll get the first few rows done. I think a lot of this will look like Pascal's triangle from the middle. So 1 and 1, 1 and 2 and 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Ten, 10, 5, 1. Actually, most of our diagram is Pascal's triangle here, because starting from the center, that ball wouldn't reach the edge until pretty far down. In fact, we get this one here too, 15. That's okay. I actually, when I shot my Plinko lesson for my online class, I made a mistake too. I didn't reshoot. I just said, here's the mistake. Took a picture of it. And yeah, so that's Pascal's triangle so far. 1 plus 6, getting this row here, 7, 21. These numbers are also in Pascal's triangle, 35, 35, 21, and 7. Then it has to make one more move to get to the bins. This is the one row where the numbers don't match Pascal's triangle. So there's another 7, you just carry it down. 28, 56, 70, 56, 28, and 7. All right, so why don't you guys finish it off? You can now see the total number of ways to reach the bottom. We can see that there's 70 ways to get 5 points. You can find the probability of getting 5 points. And if you haven't finished Plinko yet, or you just got it because you were away yesterday, kind of gives you an idea of how to do it. All right, so number of ways to reach the bottom, number of ways to get 5 points is 70. Well, I was going to try to do mental math, but that got me into trouble yesterday. 35 plus 35 plus 56 times 2 plus 70. 252, guys?
Yeah.
Okay. 52. Probability of getting 5 points. If you drop from the center, 70 over 252. Or as a percentage, about 27.78%. Yeah, so the for those of you guys who already finished your Plinko assignment, part of the idea there is to figure out, which slot to drop in to maximize your chance of getting, in Plinko, it's $10,000. Here, the best is 5 points. We don't have to redo the problem now for 1 point. I might just copy over my answers from before. We got 7, 28, 56, 70, 56, 28, and 7. Same sample space, 252. So when you're doing Plinko, especially the backside, make sure you're careful. The number of ways to get 1 point, there's actually 2 bins that give you 1 point, and they each have 28 ways to get there. So in this case, 28 plus 28, 56. Depending on the slot you do in your Plinko assignment, those numbers could differ, but here they're both 28, so probability of getting 1 point. 56 out of 252. 6 over 252, about 22.22%. Did I do okay there? You guys did the same thing? All right. So those are the kind of probability questions I'd expect you guys to be able to do with combinations. Next steps for you guys, I've got some practice for you guys to try. And for those of you guys watching online, we'll see you guys later. You can say bye. I might edit it out, but you can say bye.